Hello and a very warm welcome to part 3 of this Regentone model DP2 radio repair series. Towards the closing moments of part 2, I discovered, having applied my digital avometer, the audio output transformer primary winding is OC. Maddening though that is, I've located a used replacement type which I'd say, by its general appearance, is a genuine Regentone part. Tell you what, let's take a look. Here it is. Rather grubby and rusty, but I'd say that this transformer is going to drop straight into place onto this chassis. Moving over to the circuit diagram of this radio, T1, its primary winding, marked here as section A, is OC. Without this section of T1 being functional, the section of V3B UCL83 audio output pentode will not receive the required 255 volts DC onto its anode or plate if you are an American or Canadian viewer. Therefore, having no anode voltage, the valve will not conduct. Consequently, there will be no audio output. I'll remove the defective transformer and replace it with the functional one. Hopefully, if the triode section audio driver of the UCL83 marked as V3A is operational, we should hear some form of audio output from the speaker. Whilst I'm fitting the replacement audio output transformer, I will also replace C26. This is a Hunt's 10 nanofarad 1K audio correction or top cut capacitor. It is located from V3B anode to deck. If I didn't know better, I'd say C26, this Hunt's capacitor, is attempting to emulate a pittled walnut. Give me a few minutes whilst I fit the replacement transformer and also a replacement for this capacitor. One replacement transformer fitted, and whilst I was in the process of replacing C26 10 nanofarad top cut capacitor, I'd just as well tolerance check the cathode resistor, 270 ohms, as well as tolerance check R12 470k grid 1 bias resistor, R11 110k triode anode load resistor, R10 that is a 5.6 meg triode control grid resistor, and C22 and C23, both underneath the speaker and onto the other side, and they are 10 nanofarad at 400 volt coupling capacitors. I'll fit the 4 valves, squirt some switch cleaner into the volume control and onto the band switch, and fit the ferrite aerial rod ready for switching this radio on when I've plugged it into the mains. Okay, we'll just wait for the valves to warm up. Oh. Well, it did try to play as a tune, but no, it's not going to have it. I'll take another look and see what we can find. Okay, take two. I'll just wait for the valves to warm up. At this moment in time, this radio has two choices. It either operates or it doesn't. Ultimately, it has no choice. It is going to operate, and that's final. Sounds like Radio Sheffield on medium wave.
Claim, and finally ends by saying it's better to speak to a specialist insurer or broker direct if you have health conditions.
That sounds like BBC Radio 4.
Circumstances, something price comparison websites, it says, are far less able to do.
Okay, Dan, thank you very much. Well, we're joined now on the line from...
Not bad, all considered.
...by Johnny Timpson, who is
the problem was this rectifier, UY85.
And also
the HT voltage had reduced to something like 112 volts.
Normally reveal these things, but can you give me a sense?
As I say, I will restore this radio to a fair to good standard at my leisure. Let's take a look at the circuit diagram once again and see what I changed in the audio output section.
The industry looking at this very issue right now. I am trying to do one of the...
What has been replaced thus so far? Well, what was left of the mains lead has been replaced with a more up-to-date lead with a moulded plug and 13 amp fuse fitted. A 1K wire wound resistor has been fitted in place of R17 980 ohms heater ballast resistor. The UR85, that's V4, rectifier replaced. Reservoir electrolytic capacitor C25 32 microfarad replaced with a 33 microfarad at 400 VDC. Smoothing capacitor C24 32 microfarad replaced with 33 microfarad at 400 volts working. Audio output transformer T1 with umbuck winding has been replaced. Carbon composite resistors R14 270 ohms at 1 watt. Cathode bias resistor R12 470k grid 1 bias resistor for audio output section of the UCL 83, and R10 control grid bias for triode section of UCL 83, and coupling capacitors C23 and C22, both being 10 nanofarad, have been replaced. Now I'll go on to replace C8, 47 nanofarad AGC line capacitor, then I'll come back to you. AGC capacitor, 47 nanofarad, replaced. Here is the original Hunt's capacitor. There it is with the Hunt's name on it. Something to behold, I would say. It was not that long ago that I looked online to see whether there was a Friends of Hunt's Capacitors website. Unfortunately, I never found one. I can't think why. Now let's listen to this radio. We'll just wait for the valves to warm up.
And a 53-year-old thought to be their grandmother escaped unhurt. The cause of the fire is still being investigated.
That's a lot louder, isn't
All
it?
Saints Church in Collingham will open every day until Christmas for prayers or messages of condolence.
Try it on medium wave.
एक बात बहुत अच्छी है जो सबर आते आते ही वैसे आता है तो इसकी अच्छी बात यह है कि जब ये आ जाता है तो किसी
Fire at Chester Zoo yesterday is being treated as an accident, but the cause has yet to be worked out. Some animals, including frogs and small birds, were killed, but most of the bigger mammals were let out.
Yes, not bad at all. Vast improvement. Why did I single out C8 47 nanofarad AGC decoupling capacitor with the sole purpose of replacing it with a new unused capacitor? Yes, I know the original one fitted at the factory was one manufactured by Hunt's, but that wasn't my main reason. Honestly, it wasn't. I think that a wee bit of theoretical background will hopefully not go amiss here. Automatic gain control, or AGC, sometimes referred as automatic volume control, or AVC, is an arrangement whereby the gain of the receiver is varied automatically in dependence upon the received carrier wave amplitude. Here I'm saying as the carrier wave strength increases, there is a reduction in gain, and vice versa. The strength of the reproduced signal is not appreciably affected by normal fluctuations in received signal. Now, if the incoming signal fluctuates too much, there will be some variation in reproduced signal that will be noticeable. Why? AGC systems are not perfect, but they work quite well on the long and medium wave bands. Not quite so on domestic shortwave receivers, since there are more rapid and violent fluctuations occurring. As I say, it is not my intention to go into any great depth here. Now, it is necessary to obtain a voltage that varies with the incoming signal carrier wave. This is provided by a diode which in effect is a rectifier. The carrier wave is applied to diode from the secondary of IF transformer consisting of L7 and L8, and from there it is rectified. A negative voltage is produced at R7, stopper resistor, and R8, load resistor. There is also a DC component of that voltage which is almost equal to the peak value of the carrier wave applied by the second IFT, and that is part of the output of the AGC diode that is used for controlling the AGC of this radio. How does this happen? In short, the AGC voltage is applied to grid 1 of the frequency changer and the RF amplifier. In this instance it is V1, which is UCH81, and V2, which is UBF80 respectively, which are vari-mu valves that are controlled by the applied grid bias. This is achieved via R6, 1.8 meg resistor, thus eliminating any hint of the carrier frequency component from being fed back to the preceding stages. We therefore require a RC arrangement. The capacitance here is C8, 47 nanofarad, which provides a low impedance path to chassis for the carrier frequency in the tuned circuit and permits the AGC voltage to be applied to control grid 1 of the RF amplifier via that tuned circuit. That signal also passes via R1, 680k shunt resistor to grid 1 of UCH81. Blocking capacitor C4, 100 PF, presents the AGC voltage being short-circuited to deck through the low resistance of the tuned ferrite rod coils L1 and L2. The reason I replaced C8, specified at 47 nanofarad capacitor on the AGC line, and whilst I was working in that area of this radio circuit, I also replaced R1, 680k shunt resistor, was for the fact the capacitor was in a dried and leaky voltage condition. It gave a value reading of 85.6 nanofarad with a 5.2% V loss at 26 ohms ESR. Resistor R1, specified at 680k, gave a value reading of 941k. Since both components were way off spec, they contributed to a damping effect upon the AGC line. As I mentioned, it is not my intention to get involved in a deep restoration of this radio. I'll do that at my leisure. Not only that, I don't have all the required bits, such as an intact tuning knob. Likely I may never come across one. Nonetheless, in part 4, you will see that the chassis has been secured back into the plastic cabinet, which, hopefully, I will have had time to give it a superficial polish. Following on from there, I will demonstrate this radio's performance on both the long and medium wave bands. Then I'll conclude this repair series with a brief appraisal of how I felt this radio repair went. I bid you a very good morning. It's only 8 minutes past midnight. So thank you for your time and interest. Please join me again for part 4. Until then, bye for now.